All right. So today we're doing lecture 26 on systems of equations. The first thing I wanted to do is explain the difference between linear and quadratic. So the first thing is, you know an equation is linear if the highest exponent is 1. The highest exponent is 1. Now, you often see this when you're doing systems of linear equations. Sometimes you'll have different examples of them, like let's say you have y equals x plus 3. This x right here has an exponent of 1, so the highest exponent is going to be 1 right here. You know this equation is going to be linear. Another example, let's say you have 2x minus 3y equals 5. 2x minus 3y equals 5. Notice that this x has an exponent of 1, so that means it's a linear equation. So for all these, the highest exponent is going to be 1. Now, if you choose to go up to 2, your equation is now quadratic. So when we're dealing with quadratic equations, the highest exponent is going to be 2. The highest exponent is going to be 2. And a really good example of this is y equals x squared. Y equals x squared. The highest exponent for that x is going to be 2. So that's going to be a quadratic equation. Another example of this, we're going to be looking at this one today. Y equals x squared plus 8x plus 11. Notice that there's a lot of x's in there, but the highest exponent is going to be 2. Therefore, this equation right here is going to be quadratic. So keep in mind the difference between linear and quadratic. And what we're going to be doing today is we're going to be mixing them both. Okay? So back in Algebra 1, back in the day, you did systems of equations that looked like this. Maybe you had 2x minus 3y equals 5. And then maybe you had another equation that was, let's say, 3x plus 3y equals 10. Okay? So back in the day, you had to solve equations like this. Now for these, notice that both of the equations are linear. So this one is linear because the highest exponent is 1, right? This one is also linear because the highest exponent is 1. And you would solve these in 2 ways, right? There are 2 ways that you could do it. So you could do this by elimination. Some of you probably remember that. You could solve it by elimination. Some of you probably remember substitution. You could solve an equation by substitution. And you also have graphing. You could solve a system by graphing. So those were 3 ways that you could do it. And today we're going to be concentrating on just one. We're going to be concentrating on substitution today. So let's take a quick look at another example of a system where not everything is linear, but you are going to have linear equations in there along with quadratic equations. So let's take a look at the first example. Okay, let's say y equals x squared plus 8x plus 11, and let's get another one. Let's say y equals x plus 1. Okay, so this is a system of equations. And I know it's a system because I have more than one equation that I need to solve for, right? So the top equation is going to be quadratic. The top equation is going to be quadratic. And that's because the highest exponent is 2. That's for that x squared right there. And then notice that the bottom equation isn't quadratic. It's going to be linear, just like you're used to. So this one is going to be linear. And the reason why it's linear is because the highest exponent is 1, right? This is x to the first power. Or you can think about it this way. If you were to graph these two equations, what would you get? Well, if you graphed a quadratic equation, you would get a U shape, right? You would get a U shape. It would look something like this. And if you graphed the linear equation, you would get a line, right? It's got the word line in its name. So if you graph them, you would get a U shape and you would get a line. Now, we call the U shape a parabola. And the graph of a line is just called a line. So that's what happens when you graph them. You get a U shape and you get a line. Now, most of the times when you graph these two things, you're going to have the line crossing the parabola twice. And we're going to take a look at that when we're done with this. So the way I do this is I take the quadratic equation, I take the top equation, and I'm always going to put it on the left. So on the left side, I'm going to have x squared plus 8x plus 11. And on the right side, I'm going to have the linear equation. I'm always going to put the linear equation on the right side. So I'm going to put the x plus 1 over here. All right. So notice all the y's are gone. All you have left are these expressions that only have the x in it. That's important. The y's are going to disappear, but they're going to come back at the very end. Okay? So what I want to do now is I want to get everything on one side. Usually it's going to be the left side. So I want to get everything on the left side. That means I want to get this x over to this side, and I want to get this 1 over to this side. So how can I do that? How can I get everything on one side? Well, I've got to get rid of the x, right? And since it's a positive x, I can subtract it from both sides. Make sure you do it on both sides. So I'm subtracting x. To get rid of the 1, I have to subtract 1 from both sides. So I'm going to subtract 1. All right. So make sure you do that on both sides. That way, the two x's on the right are going to cancel out, and the two 1's on the right side are going to cancel out. So really, the only thing you're going to have left on this side is going to be a 0. Okay, so now everything is going to show up on the left side now. I've got my x squared. I bring that down. My 8x minus 1x is going to give me 7x. So I'm going to have plus 7x. And then for my regular numbers, I have 11 minus 1, which is just 10, right? So plus 10. Okay, so now everything is on the left side. Now nothing is on the right side. So the right side is just 0. So now what I can do is I can factor the left side. I want to find two numbers that can multiply to 10. They got to be able to multiply to 10, right? But at the same time, those two numbers that multiply to 10, they got to be able to add up to 7, right? The middle number. So what two numbers will multiply to 10? I'm thinking 2 and 5, right? So I can factor this as x plus 2 and x plus 5. And the right side is still equal to 0. That hasn't changed. Okay? So now I've got my two factors. I've got x plus 2 times x plus 5. And what I'm going to do is I'm going to set this up into two different equations, just like we did when we were solving quadratic equations, right? I'm going to have two different linear equations this time. I'm going to have x plus 2 equals 0. And I'm going to have x plus 5 equals 0. So all I'm doing is I'm setting those two factors up equal to 0. Okay? So now let's get x by itself. Here I can subtract 2 from both sides. Subtract 2 from both sides. And you're going to get x is negative 2. Over here, I can get x by itself by subtracting 5 from both sides. So I'm going to subtract 5. And I get x equals 0 minus 5. That would be negative 5, right? Okay, so now I've got my x values. And now the y values come in at the very end. But to find the y values, I have to substitute back in. Now, you can choose whichever equation you want. You can choose the top equation or you can choose the bottom equation. The one that you choose doesn't really matter. So I always like to go for the easiest one, which is probably going to be the bottom one. So what I'm going to do is I'm going to plug back into y equals x plus 1. So what I do first is I copy it down. So y equals x plus 1, y equals x plus 1. So I'm substituting back in. So I'm going to take these x values that I found, and I'm going to put them in for x right here and just see what happens. Okay? So over here, I'm going to get y equals -2 plus 1. But then over here, I'm going to get y equals -5 plus 1. And I'll see what happens there. Okay, so I'm just plugging in. That's all I'm doing. -2 plus 1, that's going to give me -1. So y is going to be equal to -1. And then over here, I've got -5 plus 1. And that's going to be -4. Okay. So now I've got my x values, I've got my y values, so I can write ordered pairs. When you write your ordered pairs, keep in mind that the x is always going to come first and the y is always going to come second. So over here, I've got -2 and -1. So I'm going to have -2 comma -1. Over here, my x value is -5, but my y value is -4. So I'm going to put these two numbers together. I'm going to get -5 comma -4. All right. And once you get your x, y, just like I did right here, you're done. Just make sure you always put the x first and the y second. So that's how you solve a system of equations. You basically just set them equal to each other, get everything on one side, factor as much as you can, and then you solve those two equations that you're given. All right. Now let's take a look at Desmos, because I'm going to graph these two equations and see where the two graphs meet. Where do they intersect? So that's what I want to figure out next. Okay, so here I'm at Desmos, and I'm going to input on the left side. In the first box, I'm going to type in my top equation. That's y equals x squared plus 8x plus 11. And there we go. That's my first graph. Notice that when I graph the quadratic equation, I get a U shape. So now I graph the bottom equation. That's going to be the line, right? Since it's linear, I'm going to get y equals x plus 1. So y equals x plus 1. There we go. That's that black line right there. And now I can zoom in and see where they cross. So the line is going to cross the U shape in only two places, right here and right here. -5, -4, and -2, -1. And those are the exact same answers that I got when I did it the algebra way, right? So it's all about where these two graphs are going to cross, right? Okay, let's take a look at another one. I'll leave this up there for a few seconds so you can get it. Okay, so the next one is going to be a quadratic equation on top and a linear equation on the bottom. Let's take a look at this one. All right, so just like I was saying before, you're going to have a quadratic equation on top, you're going to have a linear equation on the bottom. So let me label that. This is the quadratic because the highest exponent is 2, right? And this one is linear because the highest exponent is 1. So when I graph the quadratic equation, I'm going to get that parabola shape, which is that U shape that I want. And when I graph the linear equation, I'm going to get the line that I want. All right. So let's see what these solutions are going to be. The first thing I do is I write out my quadratic equation on the left side. So I'm going to take that x squared plus 7x plus 3, put that on the left side. The linear equation is going to go on the right side. So I'm going to take that x minus 5 and I'm going to put it on the right side. There we go. So now they're equal to each other. And the reason why I set them equal is because they're both equal to y, right? Notice how they're both equal to y over here. This is y and this is y. Well, if you remember from Algebra 1, there's this thing called the reflexive property, which basically just states that y equals y, right? Y equals y. That's kind of like saying 3 equals 3, right? It's really trivial, really basic. But basically, all that it is I know that y is the same thing as x squared plus 7x plus 3. And I know that y is also equal to x minus 5. So that must mean that these two equations also must be equal, right? I always put my quadratic side on the left, and I always put my linear side on the right. Okay? So now let's get everything on one side, make the other side equal to 0, and then maybe we can factor it or use the quadratic equation or something like that. So to get rid of this x, I have to subtract it from both sides. So I'm going to subtract x from both sides. The negative 5, I can get rid of that by adding 5. That'll get rid of the minus 5. Just make sure you do it on both sides to make them equal. So I'm subtracting x, but I'm adding 5. So let's see what happens. Now, the reason why I did that is because I want the right side to equal 0. And it does, right? But all the action is going to happen on the left side now. So the x squared is going to come down, and the 7x minus x, that's going to give me 6x, and 3 plus 5 is going to give me 8. So now, hopefully, I've got something I can factor on the left side. I want to find two numbers that multiply to 8, but at the same time add up to 6. So I'm thinking, hey, what two numbers will multiply to 8? That's got to be 4 times 2. So I get x plus 4 and x plus 2. Okay, so I factored the left side. And now what I can do is, since I have those two factors on the left side, I can set them both equal to 0. So let's go ahead and do that. I'm going to get two different linear equations. My first linear equation is going to be x plus 4 equals 0. And then my second linear equation is going to be x plus 2 equals 0. And we're going to solve them both for x. So that means I've got to get x by itself. For the first one, I can subtract 4 from both sides. So when I do that, I subtract 4 from both sides, and I get 0 minus 4. That's going to be negative 4. Over here, I've got x plus 2 equals 0. I can get the x by itself by subtracting 2 from both sides. So when I subtract 2, I get x equals 0 minus 2, and that is negative 2. Good. So now I know what my x values are. When I do my ordered pairs, I'm always going to put the x value first, no matter what. So I'm going to have a negative 4 right here and a negative 2 right here. And I still need to figure out what my y values are, right? Okay. So which equation am I going to plug back into? The top or the bottom? This one or this one? It actually really doesn't matter, because either way, whichever one I plug back into, I'm going to get the same y values. So I might as well choose the simplest one, and that's going to be the bottom equation, the linear equation, right? So y equals x minus 5. I put that right here. I put that right here. And now I'm ready to plug back in, because I know what my x values are. I can put them right back in for x if I want to. Okay, so over here, I'm going to get y equals negative 4 minus 5, which is negative 9. Over here, I'm going to plug in negative 2, so I'm going to get y equals negative 2 minus 5. That is definitely negative 7. Okay. So the negative 4 up here is going to go with the negative 9 down here. So I got to put the negative 9 next to the negative 4. So I fill in that ordered pair right here. And then for the last one, I'm going to have negative 7. And I'm done. Okay. So basically all I'm doing is I'm getting everything to one side, I'm factoring, and I should get two equations that I can solve for x with. So now let's go ahead and look at the graphs. We're going to look at Desmos, and we're going to see what the two solutions are going to look like. So I plug in the top equation, that's the quadratic. I'm going to get y equals x squared plus 7x plus 3. There's my U shape, or my parabola. On the bottom, I have y equals x minus 5. So I'm going to type in y equals x minus 5, and I should get a straight line. Yep, that's my blue line down here. Where do they cross? They cross twice, right here and right here. Negative 2, negative 7, and negative 4, negative 9. So that's a way you can check your answers. Okay. Let's look at another one. And I'll leave this up there for a few seconds. Okay. So the next one I want to do is y equals x squared minus 20, y equals x minus 8. There we go. So here I've got a top equation and I've got a bottom equation, right? The top equation is always going to be quadratic. The bottom equation is going to be linear. Just going by the exponents. So when I graph the top equation, I should get a U shape that looks like this. And when I graph the linear equation, I'm going to get a line that looks like this. And we'll see how many times they cross. All right, so let's set them equal to each other. On the left side, I'm going to have x squared minus 20. And on the right side, I'm going to have x minus 8. Always putting that quadratic on the left side. Linear on the right. Okay, so to get rid of the x, I need to subtract x from both sides and add 8 to both sides. These x's cancel out, these 8s are going to cancel out, and I'm going to get 0 for this side. On the other side, I'm going to have x squared. I don't have an x term to match x terms up, so the negative x is just going to come down. And let's see, the negative 20 plus 8 is going to be negative 12. All right, so now I have something that I could possibly factor. What I want to do is I want to multiply to this negative 12, So we're multiplying to negative 12, but we're adding up to negative 1. All right, so what two numbers can do that? 4 and 3, 4 and 3, right? But the 4 has to be negative. So x minus 4 and x plus 3. Yep, I think that's right. Yeah. Okay, so now I'm going to get two equations. X minus 4 equals 0 and x plus 3 equals 0. I can solve this one by adding 4 to both sides. That'll get rid of the minus 4. And then this one I have to subtract 3. And done. So those are my x values. How am I going to find my y values? Well, I could plug back into the top, or I can plug back into the bottom. And just to show you either one works, I'm going to plug back into the top. You can do what you want, but I'm choosing the top one this time. So the top one says y equals x squared minus 20. Y equals x squared minus 20. And now I'm ready to plug back in. So my x is going to be 4 for the first one. I get 4 squared minus 20. I know that 4 squared is going to give me 16. And 16 minus 20 is negative 4. Over on the right side, I'm going to let my x be negative 3. So I get y equals, put that negative 3 in parentheses and then square it, and then subtract 20 from that. All right, negative 3 squared, that's going to be a positive 9. Do not put a negative 9. And then minus 20 is negative 11. Yeah. Okay. So now I've got my x values and my y values. I can write my ordered pairs. So the first one is going to be 4, negative 4. I'm putting this x value with this y value. And then over here, the negative 3 is going to go with the negative 11. And that's it. And you would have gotten the same thing too if you would have plugged back into the bottom equation. So it doesn't matter which one you plug back into. Just as long as it's one of the originals, you should be fine. All right. Now let's graph them. Good. All right, so let me get rid of these and put in my new equations. So the top equation was x squared minus 20. Y equals x squared minus 20. Okay, good. I'll have to zoom out for that one. There we go. That's my U shape. And then the bottom equation should be my line. So y equals x minus 8. Yep. And then where do the graphs intersect? They intersect here and here. 2 places. Negative 3, negative 11, and 4, negative 4. So there you go. That's how you check your answer.